Here's a problem where the crate is accelerated up a ramp. A 65 kilogram crate is accelerated at 7 meters per second squared. That format's funny. Up an incline of 22 degrees with the horizontal. They give you the coefficient of sliding friction to be 0.3 and how much force is required or how much applied force is required to accelerate that up the ramp. So in order to start this problem, we got to draw a good picture. Here's the crate. It has a weight force. It has a normal force. Someone is applying a force up the ramp, and that is what we are looking for. There is frictional forces opposing that motion, parallel to the two surfaces in contact, and the angle of the incline is 22 degrees. Okay, so in the end, we need to find that applied force. Always, when we are looking at these incline problems, it is easiest to look at this as the x-axis and perpendicular to that as the y. So the only force that we need to resolve into its components is the weight force, which has an x and a y component that need to make a right angle with each other. And so with the numbers they have given me, I can find the weight force. It is going to be 65 times 9.81, and so that weight force ends up being 638. That's a little bit rounded. You might want to keep a couple more digits. I have it kind of just short on my paper. But keep a couple more digits for rounding purposes. Then once I have that hypotenuse, I can get each side of the triangle. I know that the incline is 22 degrees, so my angle inside that will be 22 degrees. When I do sine of 22, that is going to give me the x over the hypotenuse. And so my x component is going to be 239. I can repeat for cosine of 22 is the y component over 638. And so when I solve for that, I get 592 as my y component of that weight force. Then I can look at this and say, okay, how many forces are acting in the y dimension? Only two forces, the normal and the y component, are acting in the y dimension. This object is not accelerating in the y dimension, so I now know that the normal force must be equal to the y component of the weight force, and so therefore the normal force is 592 as well. I put that in my picture also, 92. That's also in newtons. Again, I'm kind of stopping at 3 sig figs. You really should keep 4 sig figs throughout the problem. The next step then is I have to look in the x dimension. How many forces are acting in the x dimension? Well, I have 3. I have the x part, or the x component of the weight force, acting down the ramp. I have frictional forces acting down the ramp, and I have the applied force, which I'm going to find in the end, acting up the ramp. The object is accelerating in this direction, so I know that these do not add up to 0. So how do I know what they do add up to? Well, in this problem, they give us the acceleration. And so if I say the net force, what they do add up to, is equal to mass times acceleration. The mass is 65, acceleration is 7, so the net force is 455 newtons. I know that all the forces in the x direction must add up to 455 newtons. Right now I only have one of those forces, which is the x component of the weight, which is down the ramp. I can find another one though, because I know the coefficient of friction and I know the normal force. Those two factors are what affects the amount of friction, and since the coefficient is 0.3 and the normal force is 592, I can get the friction down the ramp is 178 newtons. Again, keep one more digit, that would be a little bit better. And now I have 2 forces in the x dimension down the ramp. I know that the value of each of those. I'm now looking for the last force in the x dimension, which is the force up the ramp. I know that when I put all 3 of these together, that the net force must add up to 455 newtons. So there's a few different ways you can look at this. You could say, okay, I have 638 down the ramp plus 178 down the ramp, and my up the ramp has to be 455 bigger than that. So when I put all that together, it should equal my applied. I have 638, not 638 down the ramp, that's bad. 239 down the ramp, I accidentally looked at that number. 239 down the ramp, 178 down the ramp for friction, and I know that I must have 455 more than both of those in order to get this to accelerate up the ramp at 7 meters per second squared. So the applied force that I must use is 872 newtons.